what we mean by the rules of the circle. Okay. So we are going to employ the rules of the circle to find the other possible solution. Okay. So I'm going to take this image over here. Not enough. Hey. Okay. I'm going to take this image. Okay. Then we are going to construct more circle again. I'm only going to draw half of it. Okay. I don't need to use the other half. Okay. I don't waste your time. So we are going to start from -2, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Normal stress. And then we are going to have our shearing stress. Two, 4, 6, 8, 10, -2, -4, -6, -8, -10. Shear stress element rotate clockwise, shear stress element rotate anti-clockwise. Okay, I'm still going to construct our operating limits. So we know that 10 is our upper limit, -10 is our lower limit in terms of shear, and then we have our 20. Then we are going to have our first point. So it's 14. And then we have our 8. Oh, yeah, my eyes again. Ay. Okay, thank you. So we know that this is our point X. Okay. So the first point I'm going to choose, I want to have a circle. Okay. Sorry, not circle. I'm going to make sure that one of the point is at 20. Okay. Hear me out first. I want to be one of the point of the circle to be at 20. Okay. So what this means, now our join here to here as a single line. Okay. Then by applying the rules of the circle, right? By applying the rules of the circle, I'm going to take this line and I'm going to rotate by 90 degrees. Okay. I'm going to rotate by 90 degrees. Okay. So, and after rotating 90 degrees, I'm going to make sure, based on the same orientation, you're going to touch this line over here. Okay. So what I'm doing down here, you can see that this is 90 degrees, right? So this 90 degrees, if we go back to the rules of the circle, is this 90 degrees over here. Can you all see that? right? It's the same 90 degrees. Okay. So over here, this is our stress A. And over here, this is our stress B. Okay. So if we look at the rules of the circle, I just label this A and I just label this what? B. Okay. Then from here, we are going to calculate the position of stress B. Okay. So how do we do that? So we know this angle over here. I'm going to call this angle alpha. Okay. I'm going to call this angle alpha. So tangent alpha is equal to 8 divided by 246 by 6. Why 8 divided by 6? Is because this height over here is our 8. This distance over here is equal to what? 6. Okay. So alpha is equal to 8 divided by 6 inverse tangent 53.13 degrees. Okay. So from here, we know that this angle over here is also equal to alpha. Okay. If you don't believe, you just use your what? Protractor to measure. So I take my protractor to measure. Yeah, it's about 53. If I take my protractor to measure over there, yeah, it's equal to 53. If you're not sure, just use your protractor to what? Measure. Okay. Then from here, you know where is your stress A now. Okay. You can calculate, sorry, your stress B. Okay. So stress B is equal to 14 minus by 8. Wait, 8, yep, minus by 8 tangent 53.13. Yeah, yep, okay. So tangent, go on. So tangent 53.13 times 8, okay, is equal to 14 minus by 10.667. So this is equal to 14 minus 10.66. Okay? 3.3. Yep, 3.333. Okay. So now we can calculate our stress average. Okay. So our stress average 3 is equal to 3.333 plus by 20 divided by 2. Okay. So 3.333 plus by 20 divided by 2 is equal to 11.667 KSI. Okay. So now I'm going to sketch 11.667. No, hold on, undo. I'm going to eyeball these, okay? So we're going to eyeball 11.667. I'm going to draw on 12 first. Wrong color, green. Eugene. Okay. 11.667 is somewhere around here. Okay. Then this is our stress average. That's our stress average point, okay? So the stress average we calculated is from here to here. Okay. So now we just take from point X, go to the stress average point, and have our next point down here. This over here is our Y3. Okay, our Y3. So now we draw we calculate our Y3. Okay. Now calculate our Y3. Again, we are going to use the rules of the circle. Okay. So if there is alpha, right? Now, before I say how we find, let me draw the circle first. Okay, let me draw the Mohr circle first. So we know our stress A or stress B. And then I'm going to bring this up. I'm going to bring this down. Okay. So this circle belongs to our I'll draw it up here, less messy. Belongs to our XY plane. Okay, that belongs to our XY plane. Okay. So if we were to refer back to the rules of the circle, right? We know the stress average is the center of the circle, right? This angle is also equal to what? Alpha. Why? Because they share the same what? Radius, right? And this angle over here is equal to 180 minus by 2 alpha. Okay. So when that's the case, this angle over here will be equal to what? 180 minus by 2 alpha. Okay. So let me calculate what is 180 minus 2 alpha. 180 minus 2 alpha is equal to 180 minus twice by 53.13. Okay. So 53.13 times 2, 180 minus is equal to 73.74 degrees. Okay. So I measure. Yeah, it's about 73 degrees. Okay.
So, sir, could I just measure and get this, or you want me to calculate?
Because of the decimal point, right? You have to calculate. The measurement is just to confirm do you get the right angle. Because you cannot measure 73.74. Yes? Does that make sense?
Yes.
Okay. Okay, so you still have to calculate. Okay. So now you know, we know that value over there, right? And now we are going to calculate stress Y3. So stress Y3 is equal to 12 minus. Okay. So we know that we have
12 from where, sir?
Yes.
12 from where? Isn't it 11.667?
Say it again.
Where's the 12 from?
Oh, it's not 12. Yeah, it's 11.67. Oh, you are right. I was wrong. Okay. You come to McMaster, I get you a beer. Okay. So it's 11.667. Thank you.
That's the second one, sir.
Minus by, because I was focusing on getting that distance away, minus by 8 divide by tangent 73.74. Okay. So why is that? why we take that distance over there? So we know, okay, we know from here, we know the distance